Lab 4, Oscillations, Richard Morin. Introduction Instructions. This lab was broken into two parts, with part 1 being video analysis and part 2 being coding. In part 1, we were to use Tracker to find the position data of a spring system in the provided video. And in part 2, the coding, we were using the starter code, we were to compare the predicted motion and the observed motion of the mass in both the x and y directions. Additionally, we were to plot the energy changes that you compute in the model, being the change in kinetic energy, the change in gravitational potential energy, the change in spring potential energy, and the change in total energy. Purpose. The purpose of this lab was to evaluate a spring mass system both experimentally and computationally, tracking its movement through both methods. Overall, this relates to a larger purpose of understanding the physics principles behind the concept of energy and spring motion. Results preview. Through this lab, 3 things were done. The motion of the spring system in the video was experimentally found using the Tracker program. A model for such motion was created, and the results were compared and analyzed, prompting subtle differences in data, albeit the same overall trends of motion. The models and principles used in this lab were Newton's second law, the position update formula, the velocity update formula, the kinetic energy equation, the gravitational potential energy equation, and the spring potential energy equation. And then additionally, all changes in energy added was equal to 0. Rationale. Newton's second law was used for the addition of forces. The velocity update formula was used to find the velocity of objects in the system, while the position update formula used the velocity from the velocity update formula to find the position of objects in the system. The energy equations for kinetic, gravitational potential, and spring potential were used to find the different energies acting upon the objects in the system, being the spring mass. And additionally, the energy principle was used to evaluate the changes in energy experienced in the system. The system for this lab was a spring and mass, and the surroundings was everything else within the frame of the video, including objects such as the back wall. Initial conditions. The initial conditions included the spring mass was at rest, which was then given a force with the velocity being shown in the following vector on the left. Additionally, the initial energies of the system were defined. These are seen on the right. Here's the video. Through using the Tracker program, the following graph was created, plotting the x and y position data as a function of time. Here's the coding for this lab. Important coding is after the computation loop, or the calculation loop, including the calculation of forces and energy changes. These are seen in the 2 right pictures. Using this coding, these 4 graphs were determined. In the top left, the motion of the spring mass can be seen. In the top right, you can see the changes in energies for kinetic energy, potential gravitational, potential spring, and overall energy. The bottom left graph is the x position versus time for both the model and the experiment, and the bottom right is the y position versus time for both the model and experiment. Through using these 4 images, it can be determined that there are identical trends in energy change, x position and y position between the experimental and computational models. However, this does not mean they are identical, as there are slight differences in the x and y positions when comparing the experimental and computational models, specifically in regards to their magnitudes. Potential errors in this experiment include incorrect plotting of points on Tracker due to hand plotting, and that real-world conditions were used in the experiment as cannot be identically modeled in coding. In regards to this what does it mean question, in my model system, the energy principle is satisfied. This is because the changes in energy between UG, US, and K all balance to a value of 0 when the energy principle is applied. And in regards to this what does it mean question, the x position was found to be 1.6 seconds of oscillation, and the y position was found to be 1.5 seconds of oscillation. These values are roughly the same, presenting that the periods of oscillation for the spring is roughly the same regardless of evaluating the x or y position. In conclusion, overall, the motion of the spring system in the video was experimentally found using the Tracker program. A model for such motion was created, and the results were compared and analyzing, promoting identical trends and similarities. Thank you.